Hello Year 9s, this is Mrs Elliott's hand. This is going to be a quick revision of Pythagoras' theorem and trigonometry. And this doesn't relate to a specific chapter in the textbook. It was something that we did as a little extra in Year 9. So both Pythagoras' theorem and trigonometry refer to these. These are right-angled triangles, and they come in sort of different forms, but the thing that distinguishes all of them is the fact that they have one of their angles being a right angle. So what Pythagoras' theorem does is it links the sides of the triangle together. So if you know two of the sides, you can find the third side. So with this one in the middle here, I'm going to label my sides A, B and C. Notice that C is the one that is opposite the right angle. We call C the hypotenuse of the right angled triangle, and its two features are it is always the one opposite the right angle, so it doesn't touch the right angle, it's the one that's opposite it, and it's always the longest side. Okay, so here is our right angled triangle. Pythagoras' theorem states that the squares of the lengths of the two shorter sides, a squared and b squared, will always equal the square of the longer side. Okay, so I'm going to use that on one of my other triangles here. I'm going to have a look at this one here. I'm going to say that side there is 12 and that side length there is 5, and they're in centimetres. So for the triangle that we've got here, so for our example here, I know, following Pythagoras' theorem, if that's my A side, that's my B side, and that one is my longest side, my hypotenuse, opposite the right angle. So I know that A squared plus B squared equals C squared. So I literally fill in the sides that I know. So I know that 12 squared plus 5 squared will equal C squared. 12 squared is 144, 5 squared is 25. That equals C squared. Add those together, you've got 169. That equals C squared. So if I want to find my side length C, I need to take the square root. Square root of 169 will be my side length C, and the square root of 169 is 13 centimetres. Now I've deliberately chosen a nice one here that I knew would give me a whole number as my answer. That won't always be the case, so I'm just going to just make sure you can see that one, excuse me. That won't always be the case, but when you have got side lengths that are all whole numbers, then we call it a Pythagorean triple, and you might hear teachers referring to that from time to time. So a Pythagorean triple has side lengths that are whole numbers. And there are lots of these, but most of the time you're not going to come across one of these. So for example, e.g. side lengths 5, 12 and 13, because 5 squared plus 12 squared is 13 squared. 3, 4 and 5 also work. 3 squared is 9, 4 squared is 16, 5 squared is 25, which is 16 plus 9. So those ones work, and also multiples of them. So you could have 2 times that one, 6, 8 and 10. That one would work as well. It's probably disappearing off the bottom of my screen there. Okay, so that's a straightforward example where we're trying to find our longest side. What if it's one of the shorter sides that is missing? Let's have a look at an example that does that. So let's fill in some side lengths. I'll use a different colour, here we go. Let's fill in the side lengths on this one over here. We're going to say that this one's got a longer side length of, we'll say 15 metres. And we'll say that this side length over here is, we'll go for 14 metres. And this side length here, I'm going to call x, because that's what we call everything in maths that we don't know the answer to. So for this example, using Pythagoras' theorem, I've got my two shorter sides, A and B there, and I actually know my hypotenuse, my longest side length, it's 15. So we could rearrange this, but actually I'm just going to substitute my numbers straight in. I'm going to substitute in what I know. I don't know A, I've just called it x, so I'm going to call that x squared. I do know B, it's 14 squared, and I do know C, it's 15, so 15 squared. Okay, now x is the thing that I'm missing, so I'm going to say that therefore x squared is going to be 15 squared minus the 14 squared. If I subtract the 14 squared, I'll be left, from both sides, I'll be left with x squared on its own over here. So my x squared is going to be, well, 15 squared is 225. 14 squared is, I think, 196. So my x squared is going to be, oh, I think that's going to be 29. So to get to x, I do the same last step as I did in the first example. I'm going to do the square root of 29, or square root of my answer. And square root of 29 isn't going to be a nice number. Square root of 29 is, I'm going to round it to two significant figures, 5.39 metres, and that is to two significant figures. Okay, so that's an example where we have the shorter side and the hypotenuse, and we are looking for the other shorter side. So we've done one where we found the hypotenuse and one where we found a shorter side. And both times we've just substituted into Pythagoras' theorem, and then we have rearranged it so that we can find whatever our missing side is. Okay, we're going to look at a slightly different example this time. So I'm going to keep Pythagoras' theorem in the middle there. Get rid of my numbers from up here. And I'm going to look at one that perhaps isn't quite so obvious from the outset. I'm going to look at a triangle here. Now this is not a right-angled triangle. This is an isosceles triangle. And the reason it's isosceles is because I've got two angles that are the same and two side lengths that are the same. I'm going to say my side lengths are 11 centimetres. So that one's 11 centimetres and that one's 11 centimetres. And I'm going to say that I know my base, and my base length here is 8 centimetres. And what I'm going to do with this question is I'm going to A, find the height, and B, I'm going to find the area of this isosceles triangle. So I know it's isosceles because I've got two side lengths the same and two angles at the base that are the same, okay? Look out for these, they might well come up in a question. So initially I think you're probably thinking, but it's not a right angled triangle, what am I going to do? Well, what you can do on a question like this, and they put these in quite often, is you can split it into two right angled triangles. Right angled triangle there, right angled triangle there, and that is a line of symmetry on this isosceles triangle. So we've got the splitting the base into equal halves. So we've got two congruent right angled triangles here, one there and one there. So if I split my base, which was 8 centimetres into half, I've now got a 4 centimetre side there and a 4 centimetre side there. So that means that I've basically got two triangles, and I'll just draw them separately that are right-angled triangles with a length there that's 11, length there that's 4, and this is the height of my triangle, and that's the thing that I'm going to look for part A in my question. So what I've got to think about here is which ones are my A's, B's and C's from Pythagoras' theorem. Well, the C is always the hypotenuse. So the hypotenuse here is my 11, which is C. It doesn't matter which way around the other two go, the A and the B. So I'm just going to put them in like that. So using Pythagoras' theorem for part A of the question, a squared plus b squared equals c squared. Substitute in what you know. A is 4, b I don't know, but I've called it h in this question, and c is 11, so it's 11 squared. So don't forget all these squares, gentlemen, good practice of your squares. So I want to get to the h, so to start off with, I'm going to subtract the 4 squared from both sides. 11 squared minus 4 squared, so h squared is going to be 121 minus 16, so h squared is 105. To get to h, I want the square root of 105, which is going to be 10 and a bit. I'll just pop it into my calculator. Square root of 105 is 10.25, again to 10.25 to 2 decimal places. 2 decimal places. Okay, so that's my height. That's answered part A of the question. The next thing I need to do for part B is find the area. Well, the area of any triangle is half the base times the height. So in this triangle, half of the base, which is 8, multiplied by the height, which is 10.25. So I'm going to get 10.25 times 4, effectively, aren't I? Which is 41. Okay, centimetres squared, because all my measurements were in centimetres. So look out for things with these Pythagoras questions where you've got a different shaped triangle and you've got to work out what's going on. This one is an isosceles, so that lends itself. The other sorts of things that you might have to do are you might have more than one triangle connected together. So if I've got a right angled triangle here, there's my right angle, and that could be connected to, let's just say a right angled triangle here. And you might be told this length here and that length there. Not be told that one, but you're told that one there, and you've got to find this one here. This would be a 2-part question. So what you would need to do with this question is look at the triangle that you can find the third side for. Once you've found that third side, you can use that third side in that part of the question. So this triangle here, if we say that's A, that's B, and that's C. So initially, a squared plus b squared equals c squared. So we would have 3 squared plus b squared equals 4 squared. B squared would be 4 squared minus 3 squared. So your b squared would be 16 minus 9, which is 7. So b would be the square root of 7. I'm not going to put that in my calculator this time. I'm just going to leave it as the square root of 7. Okay, gents. What I'm going to do for the second part of the question, I'm just going to change colour pen. I'm going to say for this part of the question here, that side A, that can still be side B. That's my side C. So again, Pythagoras' theorem, a squared plus b squared equals c squared. Here I've got a being 2, b being the square root of 7, which I'm going to square, and that's going to give me this x value that I'm looking for. So 2 squared is 4. The square root of 7 times the square root of 7 is just 7. And that's going to give me x squared. That's going to give me 11 is x squared. And therefore the square root of 11 is going to be x. And again, you can leave it as the square root unless the question tells you otherwise. Or I'm just putting it into my calculator. And that gives me 3.32. Let's say, I'm not going to give it any units because I haven't got any, and that's to 2 decimal places. Okay, so those are the kind of things. So that's a 2-step approach. Previous one was an isosceles triangle. The more straightforward ones are just right-angled triangles. Other things that you can potentially get with these, I won't attempt to do the artistry really, but if you had something like somebody standing down here, looking up, so there's an eye, looking up at the top of a tree, there's a tree, or that's at the top of the, perhaps I'll move the top bit of my tree down a bit, there we go, top of the tree. They might say to you that the distance here is a certain number of meters, the height of the tree is a certain number of meters. How far is the person's eye to the top of the tree? So they might put it in a little bit of a diagram for you. You just need to simplify it into a right-angled triangle. Okay, last thing that I'm going to look at is a bit of trigonometry, gentlemen. So with trigonometry, we're still talking about right-angled triangles, but with the right-angled triangles, we are interested this time not just in the side lengths, but also in their angles. So right-angled triangles, but the angles are what we're interested in. And the angles, we tend to call them x or theta, yeah? X, or I quite often call mine theta, the Greek letter theta, okay? Now, what you have to remember with trigonometry, as I'm sure you can vaguely remember, is that there's a relationship between the different sides of a right-angled triangle that has a bearing on what the angle is going to be. So we already know Pythagoras' theorem links the sides of a right-angled triangle, but there is also the ratios in trigonometry that link the angle and the side lengths of a triangle. Okay, so the links that you need to remember that sine of the angle is the opposite side over the hypotenuse of the angle. The cosine is the adjacent side over the hypotenuse, and the tangent of the angle is the opposite over the adjacent sides. Now the key thing is to remember these, so you've got to remember them, and some people remember them by using so, ka, to. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That may help you to remember. But none of that is any good if you don't label your triangle properly. So just as with Pythagoras' theorem, the longest side, which is opposite the right angle, is always your hypotenuse. And then you look at the angle you're interested in the question. And the side that is opposite that is going to be your opposite side. And the side that connects to it is your adjacent side. And you must label your triangle correctly. And if you don't, you will mess up these questions. Okay, so I'm going to just do a couple of examples for you to remind you of these, and then we'll be done. So if I've got a right angled triangle here with an angle theta that we're interested in, I know that this side length here, this is a right angle, I know that this side length here is 4, and I know that this side length here is 7. First thing I do, step 1, label the triangle sides. Okay, so that's my angle, so that has got to be opposite the angle. That means that this one is the adjacent because it connects to it, and the hypotenuse is always the longest side opposite the right angle. Okay, step 2, decide which ratio to use. So the ratios that you have got are sine, cosine and tangent. Yeah, you look to see which sides you've been given, and the sides that you've been given here are the opposite and the hypotenuse. The opposite and the hypotenuse are in the sine ratio, so in this case we're going to say sine theta is equal to opposite over hypotenuse. So in this question, that's going to be 4 over 7. Okay, next thing, step 3. Use the inverse function on your calculator. So what you need to do on your calculator is to your calculator, you are going to put sine to the minus 1 of 4 over 7. And that is going to give you an angle. Okay, so I'm just going to change the settings on my calculator. So I'm pressing on my calculator. So here's my calculator. I'm pressing the shift button and then the sine button, and I'm doing 4 over 7, 4 divided by 7. And that gives me 38 point, I'm just going to do 1 decimal place, 8 degrees. Okay, I'm going to do one more example like this. I'm just going to go straight through this one. So here is my right angled triangle. This time my theta is going to be there, my right angle is going to be there. That side length there is 5, that side length there is 4. Okay, so first thing you do, label your sides. So there's my angle, that is my opposite side, that's my adjacent side, that's my hypotenuse. So I've labelled my sides. Then you choose your trig ratio that you're going to use. I only have an opposite and an adjacent side given to me, so because I've got the opposite and the adjacent, I'm going to use the ratio that's got opposite and adjacent in it, which is tangent. So tan theta is opposite over adjacent, and in this case opposite is 5, adjacent is 4. Then into my calculator I do the inverse tangent of the 5 over 4. 5 over 4, and that is going to give me, so I'm doing shift and tan, that gives me the inverse tan, 5 divided by 4, and that gives me 51.3 degrees to 1 decimal place. Okay, so the 2 examples I've done so far have shown you how to get to the to an angle. What if we've got the angle and we need to find the side, a missing side? So here we go. So this time, here's my right angled triangle. I've got an angle of 36 degrees. I know that my side length here is, let's go for 17. And I'm interested in finding what this side length here is. And there's my right angle. So first step you take is you label all your sides. You must do this. That's my opposite side. That's my adjacent side. That's my hypotenuse. Opposite the angle, adjacent, which means joining the angle, and the hypotenuse is the longest side. Then you choose your trig ratio that you've got information for. Well, I've got an angle this time. I know my adjacent side. I need my hypotenuse. So it's the adjacent and the hypotenuse that I'm using. So I'm going to use cos of theta is adjacent over hypotenuse. Now I'm going to fill in what I know. I know theta. So cos of 36 is going to give me, I know my adjacent side, that's 17, and that is over the hypotenuse, or which I'm going to call x here. I want to find x, so I rearrange this little equation. I multiply through by it. X cos 36 would be 17, and then I can divide through by cos 36. X equals 17 over cos 36. And literally you can put that into your calculator as it is to find that missing side length. So 17 divided by cos of 36, close my bracket afterwards, is 21.0 to 1 decimal place centimetres. Okay, so that's a missing side. Okay, last thing I'm going to do is one more of these, and then you'll be good to go. So let's just draw my triangle slightly differently this time. So draw it in like that. Theta's down at the bottom here. There's my right angle. And I'm going to say that's my missing side up there. Let's say that I know theta. I know theta is 14 degrees, so a little angle. And I'm going to say that I know my hypotenuse, in this case, I'm going to say it's 15 centimetres. So step one, label your triangle. This is my opposite side. That's my adjacent side. That's my hypotenuse. Then choose the trig ratio that you are going to use here. Now we need x, which is the opposite side. We've got the hypotenuse, which is 15. So the one that's got the opposite and hypotenuse in it, we're back to using the sine ratio. Sine theta is opposite over hypotenuse. Write it out to remind yourself what you need to substitute in. We know our theta, we know our angle, so we substitute that in, sine of 14. We know that our opposite side we're calling x, and our hypotenuse is 15. I want to get to x, so I need to just rearrange this formula. I need to multiply through by 15. So 15 sine 14 equals x. That is going to be our missing side. And again, just tap it straight into your calculator. 15 sine of 14, close bracket, equals x, in this case, is 3.6 centimetres to 1 decimal place. And again, these questions, so we've now done 2 with a missing angle and 2 with missing sides. These questions could be arranged into a real life scenario. So you could have somebody sitting in a boat out at sea. There's somebody up here on a cliff top, and somebody on the boat is looking up at the person at the cliff top, and there's our person at the cliff top. And we know this distance here, perhaps. We know this distance here, perhaps, and they ask us what angle they are looking up at, their angle of elevation. So you can have these real life sort of scenarios, but the main thing is to identify in your real life scenario what your right angled triangle is and what the side lengths are. Yeah. So with trigonometry, if you've got 2 sides, you can find an angle. Or if you've got an angle on one side, you can find one of the other sides. Yeah? So Pythagoras is about 3 sides. Trigonometry is about two sides and an angle. And with those 3 bits, you can always find the missing one. And that's where they are. And the link between them, this thing here, right angled triangles. Okay, I'm going to stop there, gents. You'll pick this up again in your lesson on Teams.